All right, let's jump right in. We're going to be exploring some of the most groundbreaking technologies that are set to completely reshape our world by 2026. And just to be clear, this isn't some far-off science fiction. This is the blueprint for our immediate future.
And no, that is not an exaggeration. The stakes, they've literally never been higher. Some of these breakthroughs could end up extending human life, maybe even indefinitely. At the same time, others are powerful enough to transform our entire planet, for better or for worse.
So to really get a handle on the scale of what's happening, you have to understand that this isn't just one single change. It's actually three huge revolutions, all happening at the same time, and they're transforming our planet, our reality, and yeah, even our biology.
First up, let's talk about the big stuff. We're looking at technologies that are designed to tackle humanity's greatest external challenges. Solving the really big picture problems.
It's no secret we're up against some pretty monumental problems, right? From figuring out clean energy to managing the insane frequency of natural disasters, the pressure is on for some radical new solutions. And you know what? They are finally starting to arrive.
Just look at the sheer creativity here. We've got technologies that can literally pull electricity out of thin air, others that are mimicking photosynthesis to create jet fuel from just sunlight and CO2. We're even using AI to predict catastrophic floods and wildfires weeks before they happen. The big takeaway here isn't just one of these technologies, it's the whole shift they represent. We're moving from just managing crises to fundamentally re-engineering the very systems that caused them in the first place.
Okay, so let's move on to our second revolution. This is where things get really interesting, because this is where technology starts to blur the lines between the digital world and, the physical one we all live in.
This slide shows a concept that is truly mind-bending: programmable matter. The basic idea is that we're moving beyond fixed, static objects. Imagine materials that can change their shape and function on command, like a flat sheet that suddenly becomes a tool and then just folds itself away. We are talking about a future where physical objects become as editable as a digital file on your computer.
And this new reality? It's being built by totally new kinds of workers and new kinds of infrastructure. Take extreme robotics. We're talking about machines that can learn incredibly complex assembly tasks overnight and then go to work in places that are way too hazardous for any person, like the deep sea or inside nuclear sites. And while that's happening on the ground, up in space we have mega constellations of low Earth orbit satellites, like Starlink's fleet of over 6,000, just blanketing the entire planet in high-speed internet. They're connecting the last few unconnected corners of the globe.
But of course, there's a flip side. All that power comes with some serious risks. Thousands of new satellites are creating a massive traffic jam up in orbit, which dramatically increases the danger of space debris. And when one or two companies control the planet's entire information backbone, well, that raises some huge questions about geopolitical power and who's really in control. It's a classic double-edged sword.
And that brings us to our final and maybe most personal revolution. This is the point where technology stops just changing the world around us and starts changing us from the inside out.
Take a look at this. Organoid intelligence. Now, these are not computer simulations of brains. These are lab-grown clusters of actual human brain cells, mini brains, that can learn and process information. And the really incredible part? They operate with the stunning energy efficiency of a biological brain, using just a tiny fraction of the power of an AI supercomputer.
And this leads us to one of the most profound ethical questions of our time. We are already training these organoids to do simple tasks, but as they get more complex, where do we draw the line? At what point does a tool that processes information gain some form of sentience? We have no idea.
At the same time, we're getting way better at reading the brains we already have, brain-computer interfaces, or BCIs. They're moving from just a theory into reality. Companies like Neuralink are already in human trials, and the impact is just profound. Using this exact process, patients with paralysis are now able to control computer cursors and even type, just by thinking.
And finally, we are even beginning to cheat death itself. Look at this timeline for cryopreservation. This isn't just about cells anymore. A massive breakthrough happened in 2025 when scientists successfully cryopreserved, rewarmed, and then revived a rat's kidney, completely restoring its function. This is what paves the way for banks of human organs for transplant. And it opens the door, even if it's just a little bit, to a future of indefinite biological storage and maybe, just maybe, eventual revival.
So, when we put all these pieces together, these three massive revolutions all happening at once, what does our immediate future actually look like?
Well, the transformation by 2026 is total. We're developing incredible new ways to power our world and protect ourselves from it. We are creating a brand new reality with shape-shifting materials and connecting every single person to it. And we're merging our own biology with machines, while at the same time learning how to put life on pause. This isn't some distant future. It is unfolding right now.
These breakthroughs are accelerating. They are not waiting around for us to get ready. So, the only real question left to ask is the one right there on your screen. The technology is arriving. Are we?